Howdy, everybody. Okay. All right. Let me move this over to chat. Okay. All right. For this first one, I give you two functions, f and g. I need you to tell me if they are inverses of each other. Okay, looks like we all agree. So let's go over it just so people are watching later, they can have this for it. Remember that our rule is that they are inverses of each other if f of g of x, oop, that's a 0. That's not an x. I've seen x's before, and that's not one of them is equal to x. So the idea is I'm going to take this g of x, I'm going to plug it in to f right there. Let that person in from the waiting room because I am, before I get into this. All right, good. All right, So if I do that for this problem, I will have f of g of x is equal to, instead of x, I would put 7x plus 4 minus 4 over 7. And then simplify. 4 minus 4 is 0, so this just becomes 7x over 7. 7 divided by 7 is 1, so this just becomes 1x. Hey, that's what I wanted to have. So yes, they are inverses of each other. And I'm just thinking, I've got hoo-ha for lunch today. Got leftover hoo-ha. I like the hoo-ha. I mean, the only issue is I've been ordering it to go because, obviously I think that's the safest way to get it. But the problem is their online ordering, it leaves stuff to be desired. They give you a huge portion. I mean, they give you enough to last you 2 sittings or really even 3. You could stretch it out. I mean, if you're eating healthily, let's be honest, 3 servings and this big old plate that they give you. But the problem is they don't make it exactly how I would like to make it, you know? And you can't get the pad thai or the tofu because they limit you to 10 ladles in the online ordering system. And pad thai noodles absorb a lot of liquid while they're cooking. So if they give you a big serving of pad thai noodles and only 10 ladles, it's just dry. There's like no flavor to it anymore. So you have to go with the yakisoba or the Chinese noodles. And that's not my favorite. I like the pad thai, the black thai peanut sauce. All right, I think I stoned. I'm going to clear this and move on. Okay. All right, so here's today's class. It's going to be relatively easy. These 2 things will be easy. This a little bit more difficult. If you're good, if your algebra 2 skills are great, this won't be so bad. It's really a test of your algebra 2 skills. And then this is just calculator work. This is super easy. This is just calculator stuff. So it's going to be easy difficulty, medium, and then back down to easy difficulty. All right, let's start with some easy stuff. So graph of an inverse function. The graph of a function f and its inverse function, f, using this notation right here, is not a -1 power, that's f inverse, are related to each other in the following way. If a point AB is on f, like this could be the point 2, 3, then the point 3, 2, or BA, is going to be on the inverse of f. All that happens is I interchange the x and y values, right? Remember that from yesterday? That's what an inverse does. Your x value becomes your y value becomes your x value. So functionally what that does is I can find the graph of f inverse by reflecting the graph of f of x over the line y equals x. And so that's an easy way to verify whether or not 2 functions are inverses of each other is by graphing both of them and comparing them. Okay? And to be honest, if you start working with more complicated functions like high order polynomials where you have like an x to the 4th term or even higher powers than that, solving that for x to find the inverse, it can be really difficult. In fact, some to the point where it's almost impossible to do. But graphing a high order polynomial is super easy. You can just do that in a calculator. And then reflecting it over the line y equals x is also super easy. You can do that in a calculator. So for some problems, finding the inverse can really only manageably be done by graphing it and using this method. That was a little too sweet for me, this one, the vanilla. Little too sugary. The principal, Miss Nichols, today, while I was walking through, said, well, I was talking to Brooke Waters, the other math geometry teacher, and she was like, hey, I was going to go get Sonic drinks for the math department or whatever. What kind of ones do you like? And I was like, cherry limeade. But inside my head, I was thinking, this doesn't seem 100% safe. Seems like there's a lot of contact points, especially for a drink. I don't know, maybe she'll wear gloves and it'll be fine. But the moral of the story, and then I start getting on to myself about why, I mean, come on, there's no need for you, right? This person's trying to do something nice. You don't need to be suspicious or skeptical of it at all, right? Or judgy about it at all. You should be grateful. That's what you should, like, oh, thank you so much. And that's what, of course, what I'll do is I'll accept it and be very gracious. Like, oh, thank you. You didn't have to do that. No, come on, please. You didn't have to do that. Thank you so much. It's one of those things. Like, they also put out these starbursts for all the teachers, but it's like one jar with a screw top lid. So everyone will be unscrewing, grabbing into this communal jar one starburst or however many, a handful or whatever, and then screwing the top back on and then going and eating their starburst. I'm like, how is that a good idea right now? I don't get it. All right, I think I stalled long enough. And then again, it's another thing that's supposed to be like a nice gesture. It says like, hey, you're all star teachers or whatever. There's some pun about starburst on there. And I'm like, it's all these people trying to do nice things. And it's one thing the pandemic comes like. Doing a nice thing is a lot harder now than it was in the past, I feel like. Okay, I think I stalled for way longer. Does anyone still need to write down? I know it's a big slide. No? Okay. All right, let's do an example. Okay, I think I have to stop sharing and reshare. So if you have your calculator, you should get that out now to follow along. If you don't have your calculator, you should frantically, as fast as you can, get it. Again, you can download the app right here. It's the bottom, it's right where the Zoom links you go to, right? Just below that in the comment. This link here in the middle is the one that works for most people. Will get you a calculator that looks just like the one I'm about to use. All right, so for this problem, we're asked to verify that they are inverses of each other graphically and numerically. All right, so here's how you do that. To do it graphically, we're going to, I have a scatter plot turned on right now because we do that later in class, so I'm going to get rid of that and clear out my old stuff. All right, and I'm going to type in my line. 1/2 parentheses x minus 5 and 2x plus 2x plus 5. I'm also going to type in the line y equals x, because remember, the idea is that if I graph these, this blue line should reflect over y equals x to give me this red line. And then I hit graph. You might say, Mr. Lake, you didn't hit graph, you hit zoom 6, because that will graph it in a standard -10 to 10 window. All right, and so if we look at this graph, we could say, oh yeah, it does look like it. If I reflected this red line over this black line here, I would land on the blue line. And you can really see that over here when they're close together. So that's how you verify it graphically. I would just copy and paste this graph, and I would say it looks like that a half of x minus 5 reflected over y equals x matches 2x plus 5. Or f reflected over y equals x lands on top of g. It also says to check it numerically. To do that, you hit second graph to pull up the table. And this will give you a table of your x and then the y values that go with that for each of your lines. So like this is my first one, half of x minus 5. This is the blue line. The red line here is 2x plus 5, and then this is the line y equals x. All right, and what we're looking for, again, the idea here is if I take an input like -1, the blue line gives me an output of -3. So if I compare that to the red line as an input of -3, it should give me the output that I started with, -1. Do you see how that matches? -1 gives me -3 in the blue line, and then -3 gives me -1 in the red line. They're just interchanged. -3 gives me -4 in the blue line, and -4 gives me -3 in the red line. So again, they interchange those x and y values. 5 gives me 0, 0 gives me 5, and so on and so forth. So again, I would just copy and paste this table into my work for a quiz or test, or in WebAssign, I think they have you fill in the blanks for the table. And then you should say, all right, look at that. They do match so that the input of one gives me the output of the other. And vice versa. The output of one and input, the output-input pair of one gives me the input-output pair of the other. Questions? All right, I would like you now to do this on your own. I'm going to give you 3 minutes to, and this is really, you don't have to type anything in a Pear Deck for this. This is really just a test of, do you know how to use your calculator to do everything that Mr. Lake just did? So in these 3 minutes, you need to come up with a graph that shows both of these and the line y equals x and the table for both of these. If you get stuck, this is your 3 minutes to get one-on-one help. Have me walk you through it. Oh. So I was talking about books in my last hour. And somebody told me that we're talking about Ready Player One. Um, somebody told me that Ready Player Two is coming out on November. In November, I'm like, oh, that's exciting. I've got another book series I'm reading right now, Stormlight Archive by Brandon Sanderson. He's a great author. He did the Mistborn series, which I think is his most popular work. It's very good. It's coming out in November as well, so I'm gonna have a lot to read in November. I'm already a little behind on those, but those books are huge. Each one of those is like 1,000 pages, and I'm like halfway through book 2, so I'm gonna have like, oh, it's gonna be forever since I'm reading something else. I don't even know when. I wonder if I should take a break between book 3 and book 4 to read Ready Player 2. Oh no. And every person I've talked to so far has said that they should have made a Ready Player 2 because the first one is just good enough and doesn't, and I mean, it has a great ending. I was excited about it, but now I'm not. I'm getting out all this pushback. Okay. All right. Well, I didn't have anybody ask me a question, so I think we're good to go here. All right. So next thing we're going to talk about then is the existence of an inverse function. So not all functions have inverses. Only some do. In order for it to have an inverse, it has to be 1 to 1. What that means is that for any inputs I can pick from the domain, if their outputs are the same, they have to be the same input. That's kind of a convoluted way of saying, so you know for a function, every input has uniquely one output, right? Every input has one and only one answer. This is a way of saying every output now has one and only one answer, or has only one and only one input that makes it, right? So it basically just gives us both directions now. Has to have exactly one arrow. And we work it out mathematically, it makes a little bit more sense to use this definition, but the idea here is if, let's say A is 0, and that gives me the output of 3, then if there is another number that gives me the output of 3, or it would have to be 0 as well, right? It's saying that the only thing that can have an output of 3 has to be the exact same input. No other number can work. If 1 gives me the output 3 as well, then it's no longer 1 to 1. But, okay, so that's the definition theory. It's nice to know that. But functionally, what does that mean? This is what it means. For a graph to be a function, it has to pass the vertical line test. For a graph to be 1 to 1, it must pass the horizontal line test. Okay, that's the key. So now not only does F have to pass the vertical line test, but it now also has to pass the horizontal line test, which works exactly how the vertical line test does, except with horizontal lines. Every horizontal line can intersect the graph at most 1 time. If it does that, then that function is now 1 to 1, which means it has an inverse function. So that is the most important thing that you'll write down for this. That's what you'll actually use when you're determining whether or not something has an inverse or not. Questions? All right, can I clear and move on, or does anybody need more time to write? Okay. Let's do it then. All right, determine if this is 1 to 1. So if you remember, this is one of our parent functions. So we can probably graph it by memory. If you say, no, Mr. Lake, I can't, then that's okay. Use a graphing calculator. So it is a parabola, right? This is f of x equals x squared. So to determine if it's 1 to 1, we have to ask, does it pass the vertical line test? And yes, it does. Every vertical line that we could draw through this graph will intersect it at most, that's kind of at 1 point. Okay, so every vertical line intersects it at most 1 point. Okay, the new question is, does it pass the horizontal line test? And no, it doesn't. At this point here, which we can call negative 2, 4, and at this point here, which we can call 2, 4, it intersects the graph twice. So this fails the horizontal line test. So that means f of x equals x squared does not have an inverse function. And that should make sense to you, because if I said, Gavin, if our output is 4, what is the input that produces it, right? You could tell me 2 or negative 2, right? And that's not great. Remember, we want one and only one answer. So you could say, Gavin could say 2, Osvaldo could say negative 2, right? And we could have a difference of opinions there, or somebody could say both 2 and negative 2, right? And as a result of that, it is no longer 1 to 1, one input to one output. And when I tried to write my inverse function, f with that negative 1 power, which is not really a negative 1 power, of x equals, there's no equation that I could write that would really give me, or there's no function I could write that would really give me 2 answers when I put in one input, because that's not what a function is. Function, you get one input, you get one output. All right, questions? All right, I'm going to clear and move on unless someone says nope. This is the most quiet class I've taught since the first day of school. I don't like it. This is making me feel weird. All right, let's check if you are live right now. I'm going to give you 3 minutes. Tell me, does this have an inverse function? The absolute value of x. I really like this stylus. It's got weight to it too. I always find that things of quality generally have weight. If it's lightweight, always makes me, it doesn't have to be, but always makes me suspicious as to how, you know, durable it's going to be. Oh, I think I have to stop share. Otherwise, when I try to look at the answers this time, it'll show you all what other people put. Oh, we've got a split right now. Got 1 yeppers and 3 nopers. 4 nopers. 5 nopers. 6 nopers. If you're stuck, by the way, on how to graph this on your calculator, remember to get the absolute value symbols there. You hit math, and you go right to the number tab, and then it's the first option, abs. Stands for absolute value. Okay, so if you did do that, you should have gotten a graph that looks like this. Remember, that's the V. If you look, yes, it does pass the horizontal line test, but it fails the vertical line test because, for example, at this point, the output at -2 is +2, and at this point, the output of +2 is also +2. So again, there's 2 inputs that give the same output, and -2 does not actually equal 2. That's not great, so not 1-to-1. So no inverse for you, absolute value equation. All right, questions on that? All right, let's take a break till 12:55. Actually, let's just make it till 12:55. Sorry, 11:55. But let's just make it till 12. Give you a little bit longer break here because we really don't have that much left in the lecture. So what I would do if I was you during these 12 minutes, get up, stretch, do all that stuff, use the restroom. But then I would go to WebAssign and start working on 1.6. There's also an assignment 1.7 that I put out that's due Monday. It is only 4 questions because, as I told you earlier, 1.7 is really easy. It's all calculator stuff. All right, ready? You got 11 minutes. And if you needed one-on-one help for like any of the homeworks, 1.5 or earlier, this is the time in class where you could get that. Yeah, I can do that. Oop, what did I just do? Just 1 second. I need a bigger monitor, or I need 2 monitors. Okay, that is saved. Okay, one beside. 5 or 6. Okay, I think I have to stop share, reshare, full screen. All right, 5 or 6. Consider the functions below. Determine the domain of the following using graphing and utility. Verify your results. Okay. Okay. All right, for number 1, domain of f. This is a rational equation. It has an x in the denominator, so we know that x cannot equal 0. So that means the domain would be negative infinity to 0, stop at 0, and then from 0 to infinity. For g of x, it's actually going to end up being the same thing. For x cannot equal 0, which implies that x cannot equal 0. So then, whoop, same thing. All right, remember when you're doing the composite, there are 2 steps. You have to look at restrictions for the domain of g, right here. And then you have to look at restrictions for the domain of f in terms of g of x. So we could say, instead of this, what we have to say is 1 over 4x. This, plugged in here, cannot equal 0. But actually, that is impossible already, right? If you try to solve this by cross-multiplying, you will get 1 cannot equal 0, and that's true, right? So there is no further restrictions. So the domain, actually, the answer to A, B, and C is the same. All of those have the same answer. And again, it'll give you a different red number here. I think that's actually not going to change the answer in this case. What does this do? Oh, it's just tells me points. All right, if we look at number 6. Okay, so again, domain of f is a rational function. So that means the absolute value of x cannot equal 0, which implies that x cannot be 0. So the domain is negative infinity to 0, stop, 0 to infinity. Oh, and then this was a polynomial. It doesn't have an x in the denominator of a fraction. It doesn't have a square root or fourth root or anything like that, and it doesn't have a logarithm. So there's nothing that restricts the domain here. So this domain is just negative infinity to infinity. All real numbers. All right, so again, when I'm looking at the domain of the composite, g of x has no restrictions. But we know this now plugged in here, or sorry, not plugged in there, plugged in here cannot equal 0. So the absolute value of x minus 5 cannot equal 0. Okay, technically that implies 2 things, though not really relevant, I don't think. That means x minus 5 cannot equal 0, and negative x minus 5 cannot equal 0. I guess it does, kind of. Does it? No, not really. Yeah, well, we'll see. So that means x can't equal 5. And over here, what that be? Negative x plus 5 can't equal 0. Yeah, it's not going to matter. Yeah, either answer gives us the same thing. So that this domain would be negative infinity to 5, stop, and then from 5 to infinity. Well, is that helpful? Or do you have more questions? Again, your answer for this one will not be the same because okay. Yeah. Because you have a different number than 5 there. But I had my first in-person students today. Actually kind of nice, and it was only 2 people, so they were very far apart. Oh, yeah. Okay, let me stop that. Green. Nope, that's not what I did. Okay. Um, so yes, if you haven't asked for the grant extension yet, you might do that because I don't see yours posted. I did just grant a whole bunch of people extensions. Oh, actually, I think I can do it manually. It's just not as easy. How do I do that? I think I click this, this, mm, this. Nope. I click this. Okay. This. No. Uh, can I click this? I found it. How do I do this? Uh, Okay, I think I did it for you. You should check and let me know. And if not, you're gonna have to hit that grant extension button, and then it should work it. Oh, you already did. You're already here. Okay. By the way, for everyone who's been asking for extensions, I've been putting most of them as October 7th because that's when our test is. So ideally, you get those done by next Wednesday. Which I know right now, the homework is probably impacting your grade a whole bunch because we haven't had a test in. Once we have that first test in, your grade should not change as much as it has been. It should stay, I mean, it will stay within 20% or more likely, um, with how averages usually actually work. It'll stay within 10% of your test, of your quiz and homework score combined. Because test is what your grade should be based off of, right? It's like, do you know how to do this stuff or not? I'm not going to grade you for all the practice that you did. Nope, that's not what I want. Let's try this again. I think I want, which one do I want? I think I want this one. Okay, I do. Good job, Mr. Lake. All right, it's 12:02. All right, so this is the medium difficulty thing. So make sure you pay close attention on how to do this, and hopefully you'll be fine after you do 3 or 4 on your own. Maybe 2 or 3. Finding an inverse function algebraically. Most of these steps are actually notation, but I mean, you should do them. If you want to skip over some of these steps, that's okay. The first step you should do, and this is the most overlooked step, is do the horizontal line test. It will save you a bunch of time. If the answer turns out to be no solution by the time you're done with this, you could have got that answer right at the beginning by doing the horizontal line test and telling me that it doesn't have an inverse function. The other reason why this step is so important is because you have to note the domain and range of your original function in order to get the correct answer. If you not note the domain and range, then you can do all of this correctly and your answer at the end is wrong. Step 2 is just a notation thing. Instead of putting f of x, we're going to replace it with y. I mean, they're the same thing. Y and f of x are the same thing for us. But the reason we do that is because it's easier to do algebra with y than it is with f of x. Just like for writing, it's faster to write just y. When you're doing 3y, that looks cleaner than 3f of x. Again, it's not a necessary step. You could just skip it, but I recommend it. Step C is where really most of the work is happening. You're going to then interchange your x and y values. Wherever you see an x, you put a y instead. Wherever you see a y, you put an x instead. And then you will solve your new equation for y. After you're done solving it for y, you will then replace y. You'll fix your notation and replace it with f inverse of x. And then remember that once you have a function, you know how to test whether or not it really is an inverse of another function, right? This is the test we did for bell work today. You do their composite and see if it simplifies to x. And then you'll know whether or not you got it right or wrong. Bum, bum, bum. Ba-do-do-do-do-do-do. Ba-do-ba-do-ba-do. Ba-ba-ba-do-ba-ba-da-ba-da. Ooh, hot. Hey. All right. All right, how we doing? Do we need more time to write this thing, or we good to go? Okay, nobody's telling me stop, so I'm gonna go. I'm doing it. I'm clearing. I'm moving on. All right, let's do an example. All right, f of x is equal to the square root of 2x minus 3. We need to find the inverse function. First step, I'm going to graph it. Y f of x square root of 2x minus 3. Okay, does it pass the horizontal line test? Yes. So it does have an inverse function. All right, we need to note the domain and range. So if we look, it looks like the leftmost x value we have is 1.5. The rightmost is infinity. The lowest y value we have is 0. The upmost is again infinity. Continues on forever. So, so here we go. Its domain here is 1.5 to infinity. Its range is 0 to infinity. And it did pass the horizontal line test, so it does have an inverse function. You will want to write these answers in for the domain and range down. I'm going to write, let's say you didn't have a graphing calculator, you graphed it by hand, and you're not exactly sure, you can't like use Desmos to get that 1.5 value, you again can always get that by hand. This is a radical equation, which means 2x minus 3 must be greater than or equal to 0, since you cannot square root negative numbers and get a real answer. And if we solve this for x, you don't have to write this down. I'm just as a little bit of a review. Review is always nice. It's always nice to review, right? That's how you can get that. And then if you plug 1.5 in for x, you'll get 0. Okay, but nevertheless, all right, we've done the first step. We've graphed it to confirm that it has an inverse, and we have noted the domain and range. Second step. Replace f of x with y. Again, if this is a step that you skip and just do in your head, that's okay. If the actual first thing you write down when you're finding this inverse is the next line where you interchange the x and y values, that's fine. Again, how I do that is every time I see a y, I put an x instead. Every time I see an x, I put a y instead. So if your work for the quiz or test looks like, I guess test, we don't have another quiz. Next thing we do is a test. Looks like this, and then go straight to this line, that's okay. All right, I need to solve this for y, which means I need to get rid of the 2, get rid of the minus 3, and get rid of the square root. The opposite of square rooting something is to square it. So if I square both sides, I will get x squared is equal to 2y minus 3. Add 3. X squared plus 3 is equal to 2y. I'm going to rewrite that up here so I have more room to work. Last step, to get y by itself, I'll divide by 2 to both sides. So y is equal to x squared plus 3 over 2. All right, step 4. I now replace my notation. This is really the inverse of f of x. And now look what I'm going to do here. This is why I said it's really important. If you do not write x is greater than or equal to 0, you just got the answer wrong. Here's why that's important. This is why we did this at the beginning. Remember that your inverse interchanges the range and the domain, right? So the domain of my inverse is equal to the range of my function. This range is restricted to 0 is greater, from 0, x must be greater than or equal to 0. Negative numbers are not included in this range. If this was not here, there is nothing in here to tell me that. I can plug negative numbers into this and get answers. So I have to note that I can't actually plug negative numbers in. The only numbers I can plug in are 0 to infinity. So again, it's really an easy step to do. Just whatever you got here, you copy and paste right there. That's it. And to be honest, most of the time, this is negative infinity to infinity, so you don't actually, and if it's that, you don't have to copy and paste it. I mean, it doesn't hurt to put it down. But for most times, this won't matter, because this will be negative infinity to infinity, which means that this is perfectly okay. But every once in a while, the range will be restricted, and you have to note that restriction in your domain of your inverse. All right, last, I could plug this back into here and cancel out. It does work out that it does. That way, we're kind of out of room here. So I'm going to skip that and move on to a guided practice, unless anyone has any questions or needs more time to write. Okay. All right, your turn. Find the inverse of this function. Oh. Okay, it looks like we're not. All right, I got 3 responses. I should be getting 11, either in chat or in our joinpd.com. Remember, code's top right here if you haven't joined yet. TTQKTN. So I'm gonna restart this time, and then if we need to, we'll do a breakout room to make sure everybody's got the correct answer or knows how to do it. Or if you're really stuck right now and you're like, Mr. Lake, I don't know what to do, ask for help now, and I'll help you out. Okay. All right. A little bit better here. Okay. Okay. Uh, let's go through this. All right. So let's find the inverse. First thing I would do is graph it. And what you get is a linear equation. So its domain and range is negative infinity to infinity. So you should really have no problems for this one. Oh, actually, let me write it like this. Domain and range. Negative infinity to infinity. All right, so there are no restrictions on the domain or the range, so we shouldn't have to worry about that in the last line of our last line of our work. So that's the first step. Second step, This is going to be replaced with y equals 5 minus 3x over 2. Third step, interchange the x and y values. So this becomes x equals 5 minus 3y over 2. I now need to solve this for y. So first thing I would do is get rid of the fraction by multiplying by 2. So I'll get 2x is equal to 5 minus 3y. I would copy that up here again. 2x is equal to 5 minus 3y. Subtract 5 from both sides. 2x minus 5 is equal to negative 3y. Divide by negative 3. You could write your answer like this. I'm going to go ahead and change the notation now. F inverse of x is going to be equal to, I could just leave it like that, 2x minus 5 over negative 3, or I could say that's negative 2/3 x plus 5/3. Either of these answers is correct. And note, I don't need to note that the domain is negative infinity to infinity, because that is the assumed domain unless implied otherwise. All right, questions? I know I went fast there. It's a guided practice, so hopefully you weren't following along that from beginning to end, but if you got stuck somewhere or made a negative, you caught it. Okay, let's take a break till 12:30, and then at 12:30 we will do the last portion of the notes, which is really probably the easiest part of the whole class. Again, during this time, if you have questions on homework, anything like that, please let me know. During this time, if I was you, I would be working on the homework. That's why I'm giving you this time. But again, I'm not going to tell you how to live your life. You know, it's your life. You live it how you want to live it. If you like staying up late to do homework and taking up relaxing now, I understand. I've been there. Alrighty, it's 12:30. Okay, last thing I said we're going to do is actually all of 1.7. And it should take about 10 minutes because 1.7 is just about scatter plots and correlation and finding a line of best fit. And all of that is really done on your calculator. So I think I have to reshare my screen. That way you can see both my screen and my calculator. But okay, here's an example of a problem that you'll be given. Is they have this data set. Let's say that we want to graph a scatter plot of this data set where our X values are going to be the gross domestic product and our Y values will be the population. And we will see if there's a linear relationship between those two. All right, to do that by hand is really easy. I just plot my points. So on the x-axis, I find 16.2. On the y-axis, I find 314, and I plot that point. And your TI-84, what that looks like is you need to hit the stat key, okay? And then edit, which should already be highlighted, so you can just hit enter. You'll have two lists. Clear anything else that you have in there from previous classes, or it might just be blank already. We're going to type this X list into list 1, and this are what we want to be our Y list into list 2. And so we'll type 16.2, enter, 16.7, enter, 17.4, enter, 18.1, enter, 18.6, and 19.4. Again, in the Y list, I'm going to put as list 2. So 314. Whoa, 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 whoa. All right, once you have them typed in, which I guess I'll give you a minute or two for. By the way, I'm going over this, and again, if I'm too fast for you at any point, obviously you could rewatch this video. But also, if you just go to YouTube and type in how to scatterplot, how to type in scatterplot, how to graph scatterplot, whatever, in TI-84, there are tons of videos that are like, I mean, none of them are even that long. That'll walk you through this step by step. All right, but once you have it typed in, if you hit second y equals, it'll bring you to your stat plots, and we're going to want to make sure our first plot is on. And then you can change a whole bunch of stuff. Like you can make it create line segments, you can make it into a bar graph, into a box and whisker plot. If you accidentally typed in your X list in a different list, you can change that. You can change the color, you can change the symbol that it's used, but that's all we want. Or if you hit y equals, you'll notice up here at the top, it's got these. You can go up and hit enter to unhighlight or highlight anything that you like. Now I'm going to go ahead and clear out my old equations here. All right, so you should have plot 1 highlighted. All right, you're not going to want to hit graph yet. You're going to want to hit window first, because this window from -10 to 10 is not going to show anything. So I think we would want to adjust it from, let's go from 0 to 20. Oop, not to 20. Counting by 2s is probably fine. You really don't need to adjust the scale. If you left it at 1s, it's just going to have a bunch of tick marks. It won't matter. For the Y value, I don't think I'm going to want to go 0 to 300. I suppose I could, but how about let's just go 300 to 330. Sure, let's count by 3s. And again, you can adjust these. these are just what I think would make a good viewing window. If you did 15 to 20 for X, that'd probably be fine too. Actually, I think I am going to change it. I think I'm going to change it 15 to 20 and count by ones. Again, all that counting by stuff affects how many tick marks are on the side. So really, if you just leave that at 1 and never touch it, that's probably fine. I say that, but if you had to go to 1,000, it will put all those tick marks in, which might cause you to get that spinning wheel as it computes for all 1,000 tick marks. All right, so here's our scatter plot. That's it. We now know how to graph scatter plots. Good job, us. Step 2, and this is the last slide for today, is how to find a correlation coefficient. So the idea here is we want to find the line of best fit that will go through our scatter plots. And then we want to grade it numerically on how good of a job it does. To do that, we come up with this number R, which is called the correlation coefficient. R is always a number between -1 to 1 inclusive. That represents how good of a job your linear equation is doing at matching your data. So if R is a positive number, so if it's between 0 and 1, then that means that your line has a positive slope. If the R value is less than 1 or less than 0, so it's negative, then that means it has a negative slope. And then here's probably the most important thing about it that confuses students. Is the scale is kind of weird. The middle is bad and the ends are what you want. So the closer it is to 0, the worse it is. Like this, if I drew a vertical or if I drew a line to try to match this data, it wouldn't go through very many of the dots. And the dots that it did miss would be quite far away from the line. So the line is actually not very useful at describing this data at all. So this would be like a 0.4. Be very close to 0. This would be more like a 0.9 or a negative 0.99 or 98. And this would be like a positive 0.99 or 98. This would be very close to 1. It's not perfectly linear. If I drew a straight line through this, it wouldn't go through every single dot. But the dots it does miss will be really close to the line. So again, the closer it is to 0, the worse the linear model is at describing your data. The closer it is to 1 or -1, the closer it is to the poles, the better it's fit. And so if you go later in classes, they kind of avoid that by using, instead of using R, they use R squared, because then it's just a straight scale from 0 to 1. It takes the negatives and makes it positive. Now, R squared no longer tells you the information about whether or not it's a negative or positive correlation. But at least its descriptor is a little bit more manageable. Let's try drawing an R again. How about that? Is that better? Can I not draw the letter R? That just looks so weird now. It's like when you say bowl too many times and then the word bowl looks weird. Those R's look weird to me. I don't know. Maybe they're fine. That's an R. It's just so weird. I don't like it. I'm very uncomfortable right now. Mr. Lake is not having a good time right now at all. Okay, I'm going to give you some time, and then I will show you how to find that in your calculator, and that's the last thing we're doing today. So I'll give you, I don't know, a minute or two to write this down. I'll go eat some hoo-hot. Hoo-hot. You know, it's a good movie. I think it's called Knives Out, or it's maybe, I think it's just Knives Out. Knives Out. It's on Amazon Prime right now, I think, for free. Very good movie. It's based off an Agatha Christie book. It's a murder mystery comedy. Very good. Very impressed with that movie. I don't know its rating. I don't think it's rated R. No, it's not rated R. It's like, am I going to get a complaint? Like, Mr. Lake is rating to my innocent child movies beyond that's appropriate for him or her. You should scold him. Scold him. All right. Can I start covering this up with the calculator, or does anybody need more time to write? All right, cool. Okay, so, all right. This is the most important part of class today. Absolutely most important. If you do not follow along right now, and you ask to do this later on a quiz or test, you're going to have a bad time, because I won't be able to share my screen. You need to do this. All right. Your calculator is almost certainly not set in the appropriate setting to give you the correlation coefficient. To get it in the appropriate setting, you need to do these steps, which are convoluted, but if you follow along right now, you will be fine. You need to hit second 0 to pull up the catalog. Second 0 pulls up the catalog. You are then going to press the X inverse button, which will take you to the D part of the catalog. X inverse button. Take you to the D part. You will then scroll down until you get to this setting, diagnostic on. You need to turn that on by hitting enter. Enter. I will do that one more time because of how important this is. Second 0 pulls up the catalog. You can scroll down, or if you just hit X inverse, it'll take you to the D part of the catalog. Scroll down to diagnostic on, enter, enter. Now, when you hit stat, you can go to the calc tab, and option 4 here will give us the line of best fit. You shouldn't have to adjust anything on this screen ever. If you typed your X's into list 1, Y's into list 2, enter, enter, you don't need to change the frequency or store this into your memory. Just hit calculate, and it'll give you the slope and y-intercept for the line that best fits the data. So ours is y equals 3.671 x plus 254.718. Its correlation coefficient is 0.998. So that tells us this is almost a perfect fit. It's really good. It tells us that the slope is positive, and you'll notice that the slope is positive. So if I was to type this line of best fit while I have my scatter plot graphed, 3.671 x plus 254.718, then you will see that, yeah, it goes through almost every single dot, and even the ones that it misses just barely. So this would be a really good tool for predicting future data or filling in gaps from previous data when we're analyzing what we're reanalyzing. The gross domestic product versus population. So if I want to say, all right, let's theorize that in 2020, the gross domestic product will increase by $1 trillion. What do we estimate the population of is going to be? We could use this equation and plug in, 21.4 for X to find what we think the population would be. And supposedly, it's pretty accurate at doing that. Or vice versa, we could say, all right, what do we think the economy, the gross domestic product, will be when the population is at 400 million? What will that look like? So that I could put 400 in for Y and solve this for X to find when in time, or sorry, not when in time, what our gross domestic product should be for that population. And so on and so forth. All right, questions about that, any of that? Do you need me to go through any of those steps again, or do we know how to make a scatter plot and find the line of best fit with the correlation coefficient? Okay. All right, Monday's class is going to be a little bit weird, right, because of the new schedule, but it's basically going to be a review day. So the review is going to be in WebAssign. You'll have the hour to work on that, asking me questions at your leisure. And then Wednesday next week will be the test. So the test is going to be given to you remotely. You'll basically have 24 hours to work on it from, well, not really, 7:30 to midnight to work on it. I'm going to give you, 50 minutes in class during our remote session to do it. And it should only take 50 minutes or less. It will be similar to the quiz. It'll be through WebAssign. So that means it'll give randomly generated numbers to every student for their problems. It might scramble the problems too. I'll have to look into that. I don't know if that's a setting they have or not. As a result of that, I mean, it is going to be open notes. You could use your notes. You could use the full hours if you need to. And I think I'm going to set it so it gives you 2 submissions. So you should be able to submit an answer. Maybe I'll do 3. Maybe I'll just leave it like the quiz to be consistent. I'll see what they put for their test. But I probably won't just put it 1 and done. And again, I will go through and check them all by hand because I noticed on the quiz and on the homework, there has been some formatting issues that, putting in extra parentheses or putting in a comma when you don't need to, or rounding to the wrong spot, or rounding when you weren't supposed to round. So I will go in and adjust yours. And if you want to flag something down and say, Mr. Lake, I'm fairly certain I did this correctly, but it's saying I'm wrong, can you double check? You can do that and I will double check. All right, questions about any of that? Lincoln put my badge in something like orange juice or something, and now it smells weird. He did that. Alrighty. Well, if you have any questions while you're working on the homework, please feel free to let me know. Email me. And make sure you get your homework in by Wednesday, hopefully. We have 2 assignments due Monday, 1.6 and 7. Yep. Okay. All right. Have a good day, everybody. I'm gonna go eat lunch.